Proportion and variation. When two values are related to one another, they're said to be proportional. When two quantities are connected, such as when one increases and so does the other in the same ratio, then the quantities are said to be directly proportional. And an example of what the graph would look like would be something here, where as one value increases, so does the other. So for instance, the number of packet crisps you buy and the total cost of those. If, however, as one value increases, the other value decreases by the same ratio, then these quantities are said to be inversely proportional. So the number of people building a wall and the time taken. So the more people you have, the less time that will take. And what we'll see as the graph looks something like this. Solving basic proportion questions can be easily done by applying a ratio and even some common sense. So for example, 6 books costs £8.52. What will the cost of 10 similar books be? So one way in which we could do this is we could say that 6 books are proportionate to £8.52. So we could divide by 6 to get what one book is equal to. So divide £8.52 by 6, we get £1.42. So then 10 books will cost £14.20. Part B, it takes 110 minutes to cycle 20 miles. So we could divide by 10 to get what 2 miles would be, and that would take 11 minutes. And then to get to 8 miles, we multiply by 4, so that's going to be 44 minutes. Part C, 3 men build a wall in 20 days. So 3 men, 20 days. So 1 man, well, that's going to take a much longer time to build. So if we divide by 3 on this side, what we're actually going to have to do on the other side is multiply by 3. So it's going to take 3 times as long. So that's going to be 60 days. And then to get what 5 men will be, well, we're multiplying by 5 on this side. So then we'll have to divide by 5 on the other. And 60 divided by 5 is 12 days. So it will take 5 men 12 days to build a wall. And then example D, a farmer has enough grain to feed 60 animals for 24 days. So we've got 60 animals, 24 days. If we had to feed 80 animals, so let's go down to 20 animals. To do that, we'll divide by 3. So if you've less animals, it will last longer, so we'll multiply by 3. And 24 times by 3 would be 72 days. And then to get 80 animals, we'll multiply by 4, which means we'll divide by 4, and 72 divided by 4 is 18 days. Variation. When quantities are directly or inversely proportional to one another, you can say that one varies as the other, or varies inversely as the other changes. The symbol for variation is alpha. Y alpha x means y is directly proportional to x, or y varies as x, or y varies directly as x. And each one of these 3 statements could be used, and the implication then would mean that it would be y is this proportional to x. Similarly, if we have y is proportional to 1 over x, that means that y is indirectly proportional to x, or y varies inversely as x, or y varies indirectly as x, or y varies inversely, or y is inversely proportional. And again, those 3 statements also imply this y is proportional to 1 over x. We can use this information to produce an algebraic formula for variation. So if y is directly proportional to x, then y equals kx. So our step there is to say if y is proportional to x, then y must equal kx, where k is some constant. The value of this constant can be found by substitution, given the formula connecting the quantities. If y is indirectly proportional to x, then again what we start off with is y is proportional to 1 over x, so then y equals k times 1 over x, or y equals k over x. And by multiplying up by the x, we could get it into this yx equals k version. So what we need to do is read the question and then produce this proportionality equation, either y proportional to x or y proportional to 1 over x. And then we replace the proportion symbol with an equals k. So again, our method then for variation questions, first thing we do is write the statement proportionally. So we write it in our proportionality equation. Then we write the equation it's proportional equal to, so it's equals k. So we replace the alpha with equals k. We use the given numerical information to calculate k, and then we write out the formula and use it. So in example 14, what we have is y varies directly as, and that's another way of saying that y is proportional to x. What we know then, if y is proportional to x, that means that y equals kx. Now what we're told in the question is that y equals 9 and x equals 6. So x equals 6, y equals 9. So we can put that information in and we get 9 equals k times 6. So to get k on its own, we divide by 6. And we get k equals 9 over 6. So k equals 1.5. So our equation then is y equals 1.5x. Part 2, find the value of y when x equals 15. So when x equals 15, we know that y equals 1.5x. So y is going to be 1.5 times 15, which is 22.5. Part 3, find the value of x when y is 3.75. Then we get 3.75 equals 1.5x. We'll divide by 1.5, so 3.75 over 1.5 is going to equal x. So 2.5 is equal to x, or x equals 2.5. Example B, the volume of a sphere varies directly as the cube of its diameter. So what we have then to begin with is volume varies directly means is proportional to the cube of its diameter, and the cube of a diameter is going to be d cubed, where d is the diameter. So that means that v equals kd cubed. Now we're told when d equals 6, v equals 108. So that means that 108 equals k times 6 cubed. So 108 equals 216k. So then k is 108 divided by 216, which is a half. So our formula then is v equals a half d cubed. Part 2, find the volume of a sphere with a diameter of 8. So then d equals 8. So volume is going to equal a half times 8 cubed, which is a half times 512, which is 256 cubic centimeters. Part 3, the diameter of a sphere with a volume of 500. So v equals 500. So we're going to have 500 equals a half d cubed. If I divide by a half, I'm going to get 1,000 equals d cubed. And then the cube root of 1,000 is going to equal d, so d equals 10 centimeters. Example C, the force of attraction F between two magnets varies inversely. So the key words there are vary inversely, and it's the square of the distance. So what that means is that the force is proportional to 1 over d squared. So because it said it was inversely proportional, that means it's 1 over, and because it's the square of the distance, it's d squared. And if f is proportional to 1 over d squared, that means that f equals k over d squared. We're told that whenever the distance is 6, we're told that f equals 2. So we can put that in and we get 2 equals k over 6 squared. So 2 equals k over 36. And if we multiply by 36, we get 72 equals k. So our formula then is f equals 72 over d squared. Part 2, find the force when the magnets are 2 centimeters apart. So d equals 2. So f is going to be 72 over 2 squared, which is 72 over 4, which is 18 newtons. In part 3, we're told the force is 4.5. So we get 4.5 equals 72 over d squared. Now what we do in equations where the unknown is on the denominator is we bring it up, we multiply up, and what we'll get is 4.5 d squared equals 72. So we could divide by 4.5 and get d squared equals 16, and then d is going to be the square root of 16, which is 4 centimeters. Example D, given that v is proportional to 1 over the square root of r. So from that we know that v equals k over the square root of r. So we can replace the proportional sign with equals and k. And we know from the first set of values, when r equals 1, v equals 12. So we've got 12 equals k over the square root of 1. So 12 equals k over 1. So that means that k equals 12. So our formula then is v equals 12 over the square root of r. Then the next part is to complete the table. So we've got an r value of 16. So when r equals 16, v equals 12 over the square root of 16, which is 12 over 4, which is 3. So v, whatever it happens to be, is 3. And then the last part, what we have is that v equals 3/4. So we've got 3/4 equals 12 over the square root of r. So what you might want to do is cross multiply, and we get 3 square root r equals 12 times 4, so 48. So just to be clear, we've multiplied the bottoms up. Then we can divide by 3 to leave that the square root of r is 48 over 3, which is 16, and then r is going to be 16 squared. So to remove a square root, we square both sides, so then r equals 256. So sometimes within proportion questions we're not given enough actual information to figure out the value of k. So what we do in this case is examine the relationship and use the substitution to work out how the variable changes. So what we know is that x is proportional to y squared, so that means that x equals ky squared. Now in part A, whenever we're doubling y, what we're going to have is instead of y, we're going to replace that with 2y. So that's going to look like x equals k times 2y squared, which is k times 4y squared, which is 4ky squared. So to get from what we were originally of ky squared, whenever we double it we get 4ky squared. So therefore x is going to be multiplied by 4. In part B, this time we're going to replace y with a half y, or y over 2, and then we're going to get x equals k times y over 2 squared, which is k times y squared over 4. So to square a fraction we square the top and the bottom, which is ky squared over 4. And the relationship there between ky squared and ky squared over 4 is that x is going to be divided by 4. Example 16, so given that t is proportional to 1 over L cubed, remember that's another way of saying that it's inversely proportional to L cubed. So what we're going to have is that t equals k over L cubed. So we replace the proportional symbol with equals and k. So if we double L, we're going to have L, we're going to replace it with 2L. So that means that t is going to equal k over 2L cubed. So that's k over 8L cubed. So we need to cube the 2 and the L. And then to get from k over L cubed to k over 8L cubed, what we've done to t is we've divided it by 8. In part B, if L is reduced in size to a third L, so we're going to replace L with a third L, we're going to have t equals k over a third L cubed, which is k over 1 over 27 L cubed. Now within this we've got a fraction within a fraction, which isn't very nice. So let's try and think about that in a different way. So that's k divided by L cubed over 27. So to do that, we turn the fraction upside down, so it's k multiplied by 27 over L cubed, which is going to be 27k over L cubed. And the relationship between where we were at the start of k over L cubed, we're now 27 times bigger than that. So t is going to be multiplied by 27. The last thing we're going to look at then within variation is the graphical representation of that. Now the graphs will all pass through the origin, but that's only for direct proportion. Whenever we're looking at inverse proportion, that's not the case. So if a graph of y varies directly as x, that means that they're directly proportional to. So we've got a graph of y proportional to x, so y equals kx, and the graph of y equals kx is a straight line passing through the origin, and that looks something like that. If y varies directly as x squared, what we've got is y is proportional to x squared, so y equals kx squared, and the kx squared graph is a positive quadratic, so it's a smiley shape. Y varies inversely as x, that's y is proportional to 1 over x, so y equals k over x, and the 1 over x is the reciprocal graph, and it's one of those funny shaped graphs, but we should be able to recognize its shape. So it's these two blue curves where the x and the y-axes are both asymptotes. If y varies as 1 over x squared, then y equals k over x squared, and it's very similar to the previous one, only this time all the negative parts of the graph, whenever we square them, that's going to make them positive, so it's reflected on the x-axis, and it looks like this.